Okay, so Vihan, I think you were not there in the class. Umar, do you remember what we were doing?
The reactant product.
Limiting reactants, yes. And how to calculate limiting reactants?
Wait, I
So,
was there in the class.
oh, okay. So there are two ways of calculating the limiting reactants. So I'm giving you a brief idea again. Reactant 1 to reactant 2. Check how much is given, how much is needed, and based on that, identify. This is one method. Second method is that you convert your reactant 1 to product 1, convert reactant 2 to product 1, same product, and check who is giving you less amount of the product. Whoever is giving you less amount of the product is the limiting reactant. Limiting reactant will become zero after the reaction. Like for example, we can practice one question here. There is N2 gas and H2 gas. They are reacting with each other to form ammonia. This is also a gas. All of them are gases. And if I balance the equation, I have to put 3 here, right? This is the molar ratio in the balanced equation. This is one thing. This is the equation, balanced equation, theoretical equation, and here I have the molar ratios. Now the given amount is a different thing. Now let's say I have given you 280 grams of N2 and 300 grams of H2. And the question is, what is the grams of ammonia which I can make out of this combination? Now, if you carefully observe, both the reactants are given to you. N2 is given, H2 is given. So when all reactants are given, if there are 2 reactants, both of them are given. If there are 3 reactants, out of 3, 2 are given. If more than one reactant is given, then it becomes a question of limiting reactant. Do not proceed without checking who is the limiting reactant. Because if you remember in the last class, I told you, limiting reactant is the king of calculations. King of calculations is the limiting reactant, right? So how to do it now? Kuvar, Umar?
Like
Mm-hmm.
we have like the ratio of 1 to 3 for N2 to H2, so we know that H2 is going to be the limiting reactant.
Why?
Because once you use 100 grams of
No,
N2
wait. Who is this, Umar?
Vancouver.
Kuvar. Kuvar, see here. This is the molar ratio, not the grams ratio. 1 to 3, you are saying right. But what is the ratio? What is this ratio? Is it the ratio of the grams? No. It is the ratio of the moles. So you can take this ratio only when you are dealing with moles. You have to convert this into moles then. You're getting my point, Kuvar?
Yeah.
You can do that way, convert them into moles, check the ratio, and then decide. That is also one of the way. Or you can use this method. So let's practice this method first, right, Kuvar? So Kuvar
Yeah.
is saying he's thinking is correct. He's saying that they are 1:3 ratio, but this is the molar ratio, children. This is not the grams ratio. Gram and moles, entirely different thing. Okay, equations are always given to you in moles, not in grams. So what I can do, let's do this method. Any one of you, can you recall the method? We did it last time also. Umar, you're there?
Yeah, I don't know if I remember the method.
Okay, no problem. And Dash,
Yeah,
can you help me?
yeah, I can hear you.
No, can you help me?
Oh, sorry. I wanna like watch for a little bit because I wasn't there last class, so I'm like still understanding.
Okay, so let's practice this method. Make notes in your notebook. We are practicing reactant 1 to reactant 2 to understand who is the limiting reactant. So what I'm going to do, I will start with any one of them. Anyone. Vihan, which one you want to select? Start with any one of them. Which one?
We can start with 280 grams of N2.
Very good. 280 grams of N2. This is your choice. You can start with anyone. The way I asked Vihan to start with anyone. From grams of N2, where are you going to go? Because what yeah, yes, Vihan.
Never mind. I didn't know it.
No, you were saying something.
Well, I realized I was wrong.
Okay. So I'm just targeting what Kuvar has started. 1:3 ratio. I'm also thinking that way. So, but I cannot compare grams. So, Kuvar, where should I go? I can compare moles, right?
Yeah.
So, from 280 grams of N2, where should I go? To
How
moles
many
of
moles
N2.
that is?
Yeah, moles. And then I want to compare it with H2. So, can I go to the moles of H2?
Yeah.
But moles of H2 is not given to me, so I just don't know. I cannot compare. So, can I convert this into grams of H2? And
Yeah.
then I will check this mass and compare it with what is given to me and will decide. If the calculated mass here is more than 300, this is the needed. The one which I have calculated is needed in this reaction. If the calculated mass is more than 300, then it is in excess. Needed is less, given is more. But if it is less than 300, then it means it is the limiting reactant. Are we okay with this?
Yeah.
Okay. Now you already know how to go from grams to moles. How to go? Look at the periodic table. The molar mass, that 1 mole of N2 is 28 grams of N2. You know this, right? Periodic table, molar
So 10
mass.
moles.
Yeah.
So 10 moles of N2.
Yeah, we are going to do calculation and dimensional in one go. Moles of N2 to moles of H2. Where should I go now? What should I
Come.
see? The balanced equation. And in the balanced equation, I know that 1 mole of N2 is reacting with 3 moles of H2. Agreed? I'm going to use these ratios here. Then moles of H2 to grams of H2. I will again look at the periodic table. And I know that 1 mole of H2 is, what is the molar mass of H2?
2. 2 grams.
Yeah, 2
Yeah.
grams per mole. Yeah, more accurate this, right? Now we are going to do all calculation covered in one go, dimensional. Start with what is given to you. 280 grams of N2. Plug in the first ratio to get the moles of N2. So what should I plug in?
1
Grams to
mole, 28 grams.
Moles of N2.
over.
28 grams of N2.
Very good. Don't do any calculation. Just see your unit is canceling. Yes. Okay. Now plug in the next ratio.
So 3 moles of H2 per 1 mole of N2.
Yeah. What do you want should come in the numerator?
H2.
Yeah.
Mm.
Yeah. All of you can speak. Don't worry. If voices are overlapping, still I can make out what you are saying. Then what is the next ratio?
2.02 grams of H2 per 1 mole of H2.
Perfect. Very good. Check the units are canceling. Are you getting the final unit as grams? See, most H2. Yeah, they are canceling. Cancel them. Now write the numbers, numerator numbers, and do calculation. Now show your mathematical aptitude. Over 28. How much is this?
60.6 grams.
60.6 grams. Or how much is given?
300.
Is it given more than this is needed? This is needed. And given is 300. So what is H2? Limiting reactant or excess reactant?
Excess reactant.
Excess, yeah. Given is more, needed is less. Is excess reactant. Who is the limiting reactant then?
Nitrogen.
Yeah.
Yes. So now it is the king of calculations. All calculation will be done by this 280 grams of nitrogen. All calculation. What calculation? How much amount of ammonia is formed? So that also I can do only with nitrogen. Don't use your excess. Excess is left unreacted. Can you tell me how much left unreacted? Unreacted excess left? How much is used? 60.6 gram is used.
139.4 grams.
Yeah.
Yeah, so what you are doing, Kohar?
You subtract the total amount from the used amount.
Yeah. Dash, you're there?
Yeah. I'm understanding.
Oh, you can ask questions if you missed the class of the limiting
Yeah.
reactant. I didn't take one class last week because of some electricity problem.
Yeah, this Sunday class.
So how much is this?
239.4
239.4. But now,
grams.
yeah, but now I have to take care of sig fig. I cannot put my answer in any number of significant figures. So your starting number is this. In this number, how many significant figures are there?
2.
Your answer should have only
240 grams.
200. Yeah. Very good. Okay, the way Kuvar helped me in this question in calculating who is the excess reactant. So what we did, we started with reactant 1 and 2, and we converted that reactant 1 to reactant 2 to know the excess reactant. And then we subtracted the amount needed from the amount given. That is the amount left. Now, what is the next aim? To know the amount of ammonia. That is the main question. How much ammonia is formed? Okay, grams of ammonia. That's the main question. So what I'm going to do, I'll start again with your limiting reactant. Every calculation will start with the limiting reactant. I'm clearing this. This calculation we have done for the excess reactant. Now we are going to do calculation for the product. Yes. How to start? Start with king of the calculation, limiting reactant. Means 280 grams of N2. What is the aim? To convert that into grams of ammonia. This is the aim. So can you tell me from 280 grams of N2, where should I go? And I know this relationship that 1 mole of N2 is giving me 2 moles of ammonia. That relationship I know. So I cannot relate grams with grams. I have to go through moles, right? So grams of N2, where should I go? Yes,
Moles
please.
of N2.
Yes. All of you, please participate. From moles of N2, where should I go?
Moles of H2.
Moles of H2.
No, dear. Moles of H2 work is done. What is the aim? Focus on the aim. What is the aim?
Moles of product.
Yeah. So moles of NH3.
Oh yeah, and H2, yeah.
H2 work already done. And then
Grams of grams of ammonia.
ammonia. To go from grams of N2 to moles of N2, I can use this one, right?
Yeah.
To go from moles of N2 to moles of ammonia, what is the ratio which I should use?
2 moles of NH3 for 1 mole of N2.
Very good, very good. 1 mole of N2 is 2 moles of NH3. Vihan, you're there? Vihan,
Yeah,
you're understanding?
yeah.
Okay. Then from moles of ammonia, how can I go to the grams of ammonia? Where should I look?
Periodic table.
Periodic
Periodic
table.
table, yeah. And we
We
know
have to
that,
have the molar mass.
yes. And what is the molar mass of ammonia?
Um,
17.031.
Yeah, 17.03 grams. That's the, so these are the ratios which I'm going to use. 1, 2, 3, these ratios. These are the things which I know from the periodic table and from the balanced equation. Then what are these? These are the quantities given to me in the lab when I'm working. So let's do it now. Start with what is given to you, and the significant figures will be decided from this number, that is 2. Plug in the first ratio, second ratio, third ratio, 3 ratio, 1, 2, 3. Yes, what is the first ratio, children? Grams of N2 to moles of N2. Tell me the ratio.
1 mole of N2 over 28 grams of N2.
Yeah. And the second?
One
Yes, Umar, you want to answer?
1 mole N2 over 2 mole NH3. Oh no,
What do
wait,
you?
no,
Mm,
yeah, it's the opposite. It's 2 mole
mm,
NH3 over 1 mole N2.
yes. Dash, you want to say about this, the third ratio? Dash,
Understood. Huh?
what is the, how should I plug in the third ratio?
Um, I think you would have to plug in moles to moles of sorry, moles of NH2
There is no NH2,
and
NH3.
or sorry, not NH2. What am I saying?
No, how should I plug in the ratio? Can you speak loudly? Your voice is not very
Wait
clear.
1 minute. Let me adjust my speaker.
Hey, Vihan, can you tell me the ratio? Stay
Can you
unmuted,
hear me
Vihan.
better now?
Yeah, now it is better.
Okay.
So thus you tell me now.
200.
Moles of
Yeah.
ammonia to grams of ammonia.
Yeah. So for this you have to put moles of NH3
Where?
bottom.
Yeah, and
Then on top of that you put grams of NH3, right? Or no? Wait.
grams of NH3. Yeah, you want grams of NH3, but how many grams? 1 mole of NH3 is how many grams?
1 mole of NH3, one.
It's written here.
Oh yeah.
I hope you are
17.
totally, yeah. You should pay attention totally here. Everything is written.
Yeah, no, I was searching the screen for a second. I forgot where you put it.
Okay. That's the ratio. Now check whether we have done all ratios correct. Grams N2, grams N2, moles N2, moles N2, and then moles ammonia, moles ammonia. And then just solve it. This is 10. Yeah, what's the answer?
Mm-hmm. So,
Yeah, you can use your calculator and give me the answer in two significant figures.
340.
30,
no.
No, 340.
340 grams of NH3.
NH3. Yeah.
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 Bihan, you're getting this?
Yeah.
Okay. So you've understood how to do this. So what we are doing, we are going from reactant 1 to reactant 2. This is
Yeah.
the amount of the product formed. And you know, this amount is called as theoretical yield. Theoretical means the calculated one. Theoretical
Yeah.
yield, the calculated one. That if I take 280 grams of N2, I will get exactly 340 grams of ammonia calculated on the paper. But actually, you're not going to get this much because when you're performing the experiment, errors are there. So you're expecting 340 gram, but you will not get 340 because you're dealing with the gases. Some amount will be lost during the experiment. So generally, we are getting lesser than this. And that is called as experimental yield. What you are getting is the experimental yield. What you calculated is the theoretical yield. So this method R1 to R2 is clear. Can we do another one?
Yeah.
Okay. So
Yeah.
giving you another question. So one method is that you convert your reactant 1 to reactant 2 and check how much given, how much needed. Compare, decide. Second method is that you take your reactant 1, reactant 2, convert them separately into product 1, same product. Don't take other products, same product, and check who is giving you minimum amount of the product, minimum amount. And that will be the limiting reactant. I'm giving you another equation this time.
Mhm.
Calcium is reacting, calcium oxide is reacting with carbon dioxide, giving you calcium carbonate. The amount of calcium oxide is given to us as 560 grams. CO2 is given to us as 600 grams. So both the reactants are given. Calcium oxide is given and is given in grams. CO2 is given. And the question is saying, who is the limiting reactant? Who is the excess reactant? And how many grams of calcium carbonate is formed? That's the question. This method we have already practiced. I can use this, but let's go for this one this time. So reactant 1 is grams of, let's say this is reactant 1, grams of calcium oxide. Convert that into grams of calcium carbonate. Yes. How to do it? Vihan and Dash, can you help me, both of you?
Yeah.
Yeah.
Okay.
I will start with grams of calcium oxide. Sorry. And from grams of calcium oxide, where should I go?
You need to get to grams of calcium.
Carbonate.
Oh,
Yeah.
yeah, carbonate.
How can I go?
You have to go to
So,
grams of moles of
you have to go to moles of car.
C.
Yeah. Then.
Yeah.
Then
Then you go
you
to
have
moles of
moles
calcium
of CA,
carbonate.
Then.
and then you go to grams of
And then
CA.
finally, grams of CaCO3.
Yes. How to go from grams to moles? Looking at
So
the.
in the numerator, you put what you want.
Yeah, periodic table. Looking at the periodic table, yeah, that you're telling me the dimensional. But I can go from grams of calcium oxide to moles of calcium oxide, periodic table, molar masses, moles of calcium oxide to moles of calcium carbonate, this molar ratio by looking at the balanced equations. Just check equation is balanced.
Yeah.
Moles of calcium carbonate to moles of grams of calcium carbonate, again by looking at the periodic table. So Dash and Vihan, do this calculation. Put everything in the dimensional form.
So
Cover.
first,
Wait. You do it on the paper, okay? And then you will tell me how to do here. Both of you.
Yeah.
Okay, now Cover and Omar, you can help me with this part. That convert your grams of CO2 to grams of calcium carbonate. How you're going to do it?
So first find the molar mass of CO2,
Yeah.
carbon dioxide,
Yeah, you will go from grams of CO2 to
moles,
Moles.
of CO2 to
Moles of
moles of
CaC.
of calcium
AC.
carbonate,
yeah, because
Yeah.
from the equation you can read the molar ratio only, and then to
grams of calcium
Yeah.
carbonate.
can you do this calculation?
Yeah.
Okay, on the paper, do it in the dimensional manner, cancel the units, and then give me the final answer in correct significant figure. This number has only one. There is no decimal. Only one. This number has two. Okay, so who is helping me from Vihan and Dash?
I can help.
Yeah, please.
I can.
Yeah, both of you.
First, you have to take gram CaO, and you have to do multiplication. And on the numerator, you have to put what you want, which is moles of CaO. So 1 mole of calcium, or what that
Oxide.
is, calcium oxide. And then on the denominator, you have to put the molar mass.
What is it?
I'm still trying to calculate that.
Yeah. Dash, you know the molar mass?
I'm still working on the molar mass right now, but he's thinking the same thing as him.
Yes, good. Kuvar and Omar, I have understood that you know this method very well, so you can give me final answer.
The molar mass is 56.08.
Okay. Now, what
Should
is the
be
Uh,
at
next? Yeah.
3.6.
Uh, for your answer, yes. One sig
Okay.
fig.
Okay, once.
Yeah, but
and then
when you're taking molar masses, that you have to take accurately from the periodic table.
Yeah.
Yes, Vihan. Next ratio.
then you have to take it to moles of CaCO3.
2 moles. Why?
No, I said you have to go to moles of CaCO3.
Yes. How?
Um,
Moles to moles. Looking at what is written here?
BE.
BE is what?
I
Yes.
don't remember.
Yeah, Dash, you're not helping me?
Yeah, I was. Oh, could you not hear me?
No, I could not hear you in between.
Oh, that's
Only,
weird.
what is
Yeah,
BE?
I was BE, the balanced equation.
Yes, so Vihan and Dash, what ratio should I plug in looking at the balanced equation?
Balanced. Uh, what is
1 mole of,
1 mole of carbon? Wait, what
no,
is that
look,
again? What is that? Not carbon. What am I saying? What is CO again?
see, calcium oxide. You don't know how to
Calcium
name them?
oxide. Yeah, 1 mole
Uh,
of calcium oxide. I kind of forgot for a second.
no, that's,
Or sorry, calcium. Yes.
what do you want? Vihan and
What
Dash.
do I want? The end is the calcium carbonate.
So what should come in the numerator?
CaCO3
1 mole of calcium carbonate.
Divided by?
divided one
1 mole. No. Yeah, 1 mole of
C-
calcium oxide.
Yeah.
yeah. And then
Then,
you have to get 2 grams of calcium carbonate.
mm-hmm,
And to do that in the numerator, but grams
one
calcium
mole of,
carbonate.
mhm.
Yeah.
The molar mass of
One.
calcium carbonate. What is it?
I'm trying to find that.
Yes, and then solve it and give me the answer in 2 significant figures, both of you. Okay. Now,
Yeah, I'm solving.
Hoover and
It should
Umar,
be 1,000
done?
grams.
1000 grams.
Yeah, I got 1 times 10 to the third. Yeah.
Yeah, same. Yeah, 1000 or 1 times 10 is to the power 3.
Yeah.
The same one significant figure. Okay. Can you do this calculation now?
Okay.
Check how much you are getting here.
I got the answer.
Yeah, what
I
is
got
it?
the 100.09.
Yeah. Solve it now and cancel the units just to see whether you have done the right dimensional.
I think we did it correctly.
Okay, yeah, we did. Yes, good, Vihan. What's the
So
answer now?
then, no, I'm just trying to solve.
When you miss a class, you know that videos are there.
Yeah, I know.
Okay, so just go through it. Because what you are learning now in this unit 3 is very important.
I don't know if I'm correct. I'm probably not correct. But is it, wait, actually, I don't think it's correct. Wait, would we just, since in the beginning this 560 gram CaO, that's
This
just
is
the
given.
cancel.
Yeah,
Okay.
it's given to you here in the question.
Okay.
Teacher has given you 560 of this, 600 of this. Then you converted 560 grams of CaO to calcium carbonate. The question is what is the answer? Are you sure, children, this is 1000? Boys, 600?
I'm thinking.
In 1/6, yeah, that's what I got.
Yeah, in one sig fig.
Okay. 1 sig fig is too much of error. Divided by in 1 sig fig. Can I change the number of sig fig? Because then otherwise I won't be able to compare.
Okay.
So can we put it in 3 sig fig? I place a decimal here.
Okay. Will that be 1,360 grams then?
Yeah.
1360, yes. This is better because then answers are nearly same. You calculated this one?
Yeah, I did.
How much is this?
And how many sig figs?
2. Let's do it in 3. This one also.
Okay, just give me
Harsh
a
and
sec.
Vihan, we are
Yeah.
working with 3.
Yeah. I know.
How
Is it
much?
999 grams?
990.
I got 986, but I'm probably wrong. I don't think it
No,
is.
it's okay. This number can be 99. This can be 96. Last digit can be uncertain. Grams
Okay.
of CaCO3. Are you getting this, Vihan and Darsh?
Yeah. Yeah.
Yeah, you're getting 999 or 996?
Hmm?
Are you doing calculations?
Yeah, I am. I am right now. Mm. Mm.
Vihan, you're getting this answer?
I'm
So very
still trying to find out.
what?
So I'm still a little bit confused on the next step.
Calculation, dear. Just calculate. What is the
Yeah,
numbers in the numerator? Pick
in
up
the
your calculator and just calculate. That's it. You have done everything. Divided
yeah.
by,
Oh, that's the thing. So I actually did the same thing, but I forgot to divide by 56.08. So that's why I was getting the wrong answer.
yeah, that is the reason I'm always telling that after doing this dimensional, write all numbers separately so that you can see every number carefully. Do not leave any number because if you leave the number, your answer will be wrong. Umar, I'm also getting the same number, 999 point
Yeah, I think I just
something.
made a mistake in the
Yeah.
calculation.
So who is the limiting reactant? Whoever is giving you the
Calcium
minimum
oxide.
amount. Say again?
Reactant.
Calcium oxide.
Yes. So limiting reactant is,
Calcium.
yeah. And how much calcium carbonate is formed?
999 grams.
Yes. Then this amount has
Yeah.
nothing doing with your calculation. This calculation with the excess, this is the excess reactant. This calculation is a waste now, right? Don't look into it. Don't pick up any number from here because this is going to be wrong. All calculation will be done by limiting reactant. Vihan, you have with the answer?
Yeah.
Okay, now this is one part that how much product is formed. Now who is the excess reactant here? Limiting is calcium oxide. Excess is CO2.
And dioxide.
Yeah. Now the next thing is how much excess is left? This is another part of the question. How much excess is left? Can we do that?
See.
Oh, sorry. I have to put this number back because these are the amounts given to us.
Mhm.
Our question is based on these amounts. How much excess is left? How to do this? Yes. Who is the king of the calculation now?
Limiting factor.
Yeah.
Calcium oxide? So start with 560 grams of calcium oxide and convert that into grams of CO2. This gram of CO2 which you are calculating by using this method is the amount used. Right? It is the amount which is consumed. Then subtract this amount from the given amount, the way we were doing in the previous question. So ready? So tell
Yeah.
me how to set up the ratio. From 560 grams of CaO, where should I go?
Moles.
Yes, always grams to moles, always. Because you can
And
read
then
the equation in terms of moles only.
moles of CO2.
Yes, by looking at the balanced equation.
And
And
then
then,
grams of CO2.
perfect. Very good, Vihan. Now
And
let's,
the way you go from grams of calcium oxide to moles of calcium oxide, I think it's by
using
periodic
the, yeah,
periodic
molar mass from the periodic table. And
Mhm.
moles to moles?
balanced equation.
Yes. And moles to grams?
Moles to grams. I'm not sure for that one.
Why? You are sure about grams to moles? Moles to gram is the same thing. Periodic table,
Mhm.
molar masses.
Oh yeah, okay.
Okay. Can you calculate it? Dash, you are
Yeah.
going to help me. Rest of
Okay.
you, I think you have understood. Dash is helping
Yeah.
me and you do your calculation and
Yeah.
then we'll
All right.
check the answer. Dash, help me here.
Yeah. Okay. So 560 grams.
Of calcium oxide
Yeah.
times
Uh,
grams to moles.
grams to moles. Yeah. Sorry, one
So
second. Drop pencil. Yeah, I got it. All right. Yeah. Grams to moles. So over the conversion was 560 grams.
I've started with that.
Or sorry, not
Now,
560 grams. You
what
already got
ratio?
500.
Yeah. What
The
ratio should I
ratio,
plug in?
um, the
Look at the
there's,
periodic table.
Wait,
I'm looking at
are we doing
the,
three sig? I mean, two sig figs?
3.
Three? Okay. Oh yeah, decimal.
Yes, Dash, fast.
yeah, so looking at the periodic table real quick.
You already
Um,
calculated here in this one.
oh, we
50,
did?
yeah. This is the
Oh,
limiting
okay.
reactant. You
So
already know.
56.01
Where?
grams over 1 mole,
No,
or so other way around.
other way around. 1
Yeah,
mole of
sorry.
calcium oxide
Yeah,
divided by 56.08 grams of calcium oxide. Then the next
yeah.
ratio.
Okay, now to go to moles of
Looking at the balanced equation, right?
yeah, the balanced equation. There it is. Yeah. So now we have to go to moles of CaCO. So that's just 1 mole of calcium oxide to 1 mole of
So
carbon
what should I
dioxide,
put
right?
in the numerator
So the numerator is 1 mole carbon dioxide, and denominator is 1 mole
of CaO?
uh, yeah.
Mole CaO cancel. Then next, what is next?
Right. Okay. Then
Next
next we have to
ratio.
convert back to grams. So you use the CO2 grams to moles
Yeah, give me that.
conversion.
Yes.
Yeah, that
What should
was,
what should I put in the numerator and
I
denominator?
think it was, yeah. So, in the Later, you put 1 mole of CO2, and numerator is 100.09 grams of CO2, I think.
What? CO2, molar mass.
Oh shoot, wait, oh my god.
Periodic table.
Never
Look at
mind.
the periodic table, molar mass.
Yeah.
What is that?
Oh yeah. It's 44.01,
Grams of CO2.
yeah.
Yeah. Okay, now do the calculation. Yes, what is the answer? So, Dash,
Okay.
you need some practice.
Yeah, I
You're
do.
slightly, yeah, slightly shaky in this dimensional. Umar is saying
Yeah.
is 1.00 times 10 raised to power 3. Oh, Umar, what you calculated? We are calculating CO2, right?
Oh, wait. Oh, hold
Yeah,
on.
you calculated calcium carbonate, which you calculated earlier. Calcium carbonate we have calculated from the limiting reactant. That part is done. We already know how much calcium carbonate we are going to get. That part is done, right? Here,
Yeah.
this red box. So we know that we are getting 999 grams of calcium carbonate. Now we are working for carbon dioxide. Over you are there?
Is it
440.
440 point grams of CO2?
Yes.
Oh, yeah, I
Yes.
need to put the point. Yeah.
Yeah,
The-
put the point. Yes. 440 point grams of CO2. But how much is given?
600,
600,
So how much is left unused?
160.
160.
Yeah, left unused. Vihan and Dash.
Yeah.
You're understanding this part? Left unused.
Yeah, now I'm understanding.
Yeah, good. This is the amount which will be left unused of the excess reactant. CO2 is excess. And that is, they are saying 160. Yeah. Put a decimal there. So that's the meaning of the limiting reactant and calculation of the limiting reactant. Now we are going to see some simple questions. Ready for it? These are the complicated, ultimate questions. Now simple questions should be very simple for you. Read this question. Who is the limiting reactant? How to decide who is the limiting reactant?
You have to find which one is
You
left
can
over,
use
and
this,
then
yeah, leftover.
the one that's not left over is the one that's limiting, basically.
Yeah, so can we do this R1 to R2 method here? How much A is given? 4?
4 moles.
So 4 moles of A. Let's start with that. Convert that into moles of B using this molar ratio. So 4 moles of A will react with how many moles of B?
2 moles of B?
No, what is the ratio?
4
What is
to
the
2?
No, where?
Like it says
Hey,
here
this
react.
is given. This is given. This is
Oh,
not.
3 moles of
Yeah, this
1 mole of B.
ratio. Yeah, this ratio is from the balanced equation. These are the given. It can be in excess, right? So you're going to do this. 1 mole of B over 3
3
moles
moles of
of.
A.
How much is that?
4 over 3 moles of B.
Is it 2? No. So this is the one which has reacted. How much is left unreacted? Unreacted B.
2/3 moles.
Okay.
Mole will be 2.
No, you're confused again. How much is given? 2.
Yeah.
And how much has reacted?
4/3.
This. So 2 minus 4 over 3. How much
So
is
2/3.
2 over 3
So yeah, 2/3.
left. Vihan and Dash, are you understanding this?
Yeah, I'm understanding.
Yeah.
Vihan,
Yeah.
whenever I'm doing this, how much left unreacted? Both of you are very quiet. Okay, this
Oh,
is
yes.
how you can decide who is the limiting reactant.
Limiting
B.
reactant here.
Who is it?
B.
B.
B is left unreacted, isn't it?
I mean A.
Yeah.
I meant A.
So,
B is
oh,
left
wait, yeah.
unreacted.
Mm-hmm.
So A is the limiting reactant.
Mm.
So is this line correct? You need 6, but they have given you 4. Is it correct? Is
Yeah.
A given to you in excess? They are saying 4, right? But they are saying you need 6. How come we need 6? You do this. You start with 2 moles of B and convert that into moles of A. Can we do that? Yeah, tell me the
Yeah.
ratio.
2 moles of A
B.
over 2 moles of B over 3 times 3 moles of A over 1 mole of B.
Yeah. Kuvar is speaking and learning.
Yeah.
Umar, you are clear about it? How he's taking this ratio?
Yeah.
Moles B cancelled. So how many moles of A are needed to react with 2 moles of B?
6.
And how
6.
many are given?
4. 4.
So it means
So
A is the limiting
yeah.
reactant. Given
So
is
B is right.
less. Yeah. So B is right. B is the limiting reactant? No. B is not the, neither reactant is limiting. No, definitely one reactant has to be limiting. The limiting reactant is the one with higher molar mass? No. It has nothing doing with that. It is just the how much is left, how much is used. So are we clear about our answer here? Vihan,
Yeah.
is it confusing? Vihan?
A little bit.
Yeah, that's got it.
Okay. So where is the confusion, Vihan? You are not asking questions? Okay, let's do one more question. We'll understand here. This time I'm going to put things in a very different manner, which I think I told you in the last class also when I introduced you with the limiting reactant. First, we are writing the balanced equation and all the information in the paper like this. This is the balanced equation. Then I'm saying initially, before the reaction. Can you tell me how much O2 is given? Read the question.
10 molecules.
10. And how much ammonia?
10.
Yeah. And how much NO in the container?
0.
And how much water?
0.
Now, yeah, they are saying how many total molecules are left after the reaction. So finally, I have to see all these molecules after the reaction, and I have to add all of them to get the answer.
So it's 20.
So it's a limiting reactant, right?
Yeah.
Okay. So how to decide the limiting reactant? Which method you want to follow? Reactant 1 to reactant 2 or reactant 1, reactant 2 to product 1? Which one you want to follow? Pick up your choice.
Reactant 1 to reactant 2.
Oh, you're happy with that? Okay, let's do that. So start with 10 molecules of ammonia and is going to react with how many molecules of O2? Calculate that. The equation which is written here, you can read it in terms of moles and you can also read it in terms of molecules. So you have this ratio. 4 molecules of ammonia from the balanced equation, molar ratio. 4 molecules of ammonia are reacting with 5 molecules of O2. This is the ratio.
Okay. Yeah.
Mhm.
So let's do it. So what should I plug in? Yes, please, all of you are free to answer.
Yeah, okay. So times now you have to change it to molecules of O2. So convert it.
Yeah, Umar, you know it? Please feel free to answer.
Yeah.
No answer?
Did you do moles?
No, molecules, you can read the equation in molecules also. 4 molecules reacting with 5, giving you
Okay,
4 NO.
so 5 molecules of O2 over 4 molecules of ammonia?
Yes. The balanced equations we can read in terms of molecules, in terms of moles, in terms of atoms also, ammonia, but not in terms of grams. Umar, you're understanding this?
Yeah.
So what's the answer?
50 over 4
Yeah.
molecules of
Because yeah.
50 over 4 is how much? 25 over 2? So
yeah,
12.5.
12.5.
And how much is given?
10 molecules.
So is O2 limiting reactant or excess reactant? This is needed, the one which you have calculated.
Limiting.
Limiting,
Yeah.
limiting reactant.
So what will happen to the limiting reactant finally? It will become 0. Put 0 here, final,
Because it
because it is the
burns
limiting
up or
reactant.
stops limit.
Yeah. It's completely used up, nothing left. Reaction is going to get stopped because limiting reactant has become 0. So there is no reaction after that, right?
Yeah.
So
So if we have more of the limiting reactant, then it won't be limiting, and then the reaction will continue.
yes, yes. Now
Okay.
every calculation has to be started from the molecules of O2. So start with 10 molecules of O2 and convert that into molecules of NH3. Convert that into molecules of NO and convert that into molecules of water. So I'm giving you task. This part is given to Kuvar and Umar. Can you do molecules of ammonia? 10 molecules
Is
of
it
O2
8?
will react
Yeah, 'cause you
8?
just swap it, yeah.
8.
Yeah,
Yeah, 'cause
8
it's
Okay.
molecules.
40 over 5.
Of ammonia. And how much is given?
10.
10.
So how much is left?
2.
2.
So shall I put 2 here?
Yeah.
Yeah.
Okay. Vihan and Dash, Ammonia is the excess reactant. Only 8 molecules of ammonia has reacted. Out of 10, 2 are
Yeah.
left.
Yeah, so yeah.
Okay.
Now, can you do this? Molecules of NO? Vihan and Darsh.
Okay.
How many molecules of NO are formed? And Kuvar and Umar, can you do this? Water. Give me the molecules of water formed.
Is it 12 molecules of water?
12 molecules of water? Okay.
Yeah, because
I'm
10
still
times
doing it.
6 over 5.
Yeah. You're also getting the same, Umar?
Yeah, I just got it.
Yeah. Okay, so we are going to write water as 12 here. 12. These boys, what are you doing? Vihan and
I'm
Dash.
working. I'm working now.
Why people are taking so much time, Vihan?
Yeah.
Start with 10 molecules of O2. Plug in the ratio. What ratio? From the balanced equation, 4 molecules of NO divided by 5 molecules of O2. So simple. Yes, Dash, isn't it?
Yeah.
So it's 5. I
No,
mean 8.
No,
8, yeah.
it's 8.
So
Yeah.
put 8 here. Now answer this
Okay.
question. How many total molecules
Total
are present?
All right. So there's 8 there. There's
How many
that
total?
there.
Mhm. Total means just add all of them in the final scene. Final
No.
scene, just add them.
Yeah. So it's just 2 plus 6. 20.
22.
Oh yeah, I missed the 2 there.
2, 8, 12. 22 molecules will be there in the container finally. Visualize the solution, the container, what are initially given, what all are left after the reaction, and add all these molecules to get the answer. Yes, Kumar and Umar, is it okay?
Yeah.
Okay,
Yeah.
that's a very, very important concept, limiting reactant. So we'll do more questions, more practice in the next class. Next class, we'll be doing work with the limiting reactant, theoretical and percent yield, which is also based on limiting reactant, and then types of reactions. So see you on, okay, you people are not doing quizzes? Yes, Darsh, are you doing quizzes?
Yeah. I'll catch up on them.
Yeah, I'm going to share the result of unit 0, 1, and 2. 3 have just started. So I'm not expecting you to do all of them in one day, but please try to finish all your left quizzes
Yeah.
from
Yeah.
0,
Yeah.
1, and 2.
Okay.
Wait,
Yeah.
I have
Yeah,
a
I'm
question.
sorry. I had a lot of schoolwork, so I wasn't able to
Yeah,
do it
same.
yet.
So Saturday, Sunday?
Yeah, the thing is
Okay.
that Saturday I have like soccer practice and then like shadowing and stuff, so I just didn't get time.
Yeah.
Oh, okay.
Okay. Bye.
Bye, bye.
Wait, I have a question.
Yes, yes. Rihan.
Goodbye.
So
Bye, bye.
on my the chem topper, when I go there, it says for some quizzes that I've done, it's saying that you haven't got the grade for it because your teacher has to grade it.
Oh,
So does
okay,
that
okay.
mean I should,
Oh, okay.
because
No, no.
I've done
Uh,
it like 2 3 times.
yeah, it means that there is some question in which you have typed the answer. I'll check that, Vihan. Thanks for reminding me. Okay.
Wait, when do we have to complete the quizzes by? Because I have some of the unit 2 quizzes to do.
When you,
Like when are we supposed to complete it by? The unit 2 quizzes? By Sunday?
Yeah, before the next class, Unit 2
Okay.
is way back done, right?
Yeah.
Unit 2. There are 7 quizzes and they are simple. Do it. Finish them,
Yeah.
okay?
Okay.
And
All
don't
right.
worry about
Okay.
the marks, it's just practice.
Yeah.
Unit 3
Okay.
quizzes, they are already uploaded. These are simple ones, 3.1, 3.2, 3.3. Keep doing them, right?
Yeah.
Okay,
Okay. All right.
okay.
Thank you. Bye.
Bye, bye.